Let's move along to something a little bit more challenging. Example E. Again, we're going to multiply this monomial, this term, or this factor 1/2, into the bracket. So 1/2 times 36, 18k, and 1/2 times negative 20. We take a look at these two terms. Variable of k, no variable at all. These are not like terms. You cannot combine them and simplify them. Let's take a look over here. We multiply the 1/2 times 2n, 1/2 times negative 6m, 1/2 times 1/4, and then stop. We do not expand that 1/2 outside the bracket to the negative 4m. So now we just multiply the 1/2 times the coefficients. 1/2 times 2, or 1/2 of 2, is 1. The variable is n. 1/2 of negative 6 is negative 3m. And 1/2 of 1/4 is 1/8. And then this negative 4m just stays where it is. So we look at all the terms. So we see we've got an n, we've got a negative 3m, we've got a 1/8 constant, and a negative 4m. There are two like terms there. Negative 3m and negative 4m. Same variable, exact same exponent. Those are like terms. Those ones we can combine together. So I'll leave, because these two are negatives, I'm going to leave this n here. I'll combine the negative 3m, or collect the two terms with m, negative 3m and negative 4m, plus 1/8. And now we will combine those two terms. Now when you combine terms, it's not like when you multiply. We've just got negative 3m, like some objects, like say, I don't know, monkeys. Negative 3 monkeys minus 4 monkeys, which gives us negative 7 monkeys. The monkeys do not change, we're just adding them together. Combining negative 3 with negative 4 to get negative 7, the monkeys do not change. Now we look at the three terms. None of them are like terms. We cannot add them together. Moving along to example 2, we want to determine the missing factor and verify. So now we see we're multiplying something by 2x and by 3, and after that's finished we get 8x plus 12. Well, what do we multiply by 2 to get 8? That would be 4, and let's see if that works when we multiply by 3. 3 times 4, it does give us 12, therefore 4 gets multiplied there. And kicking up a notch here, we're going to multiply 3x squared times this, 3x squared times this, and 3x squared times negative this, which will leave us with 9x to the power 4 plus 12x cubed minus 3x squared. Well, what do we multiply 3 by to get 9? That would be 3. What do we multiply 3 by to get 12? 4. And what do we multiply 3 by a negative to get negative 3? Well, the subtraction is already there, or the negative, so we just have a 1 here. And then x squared times something gives us x to the power 4. Again, you're multiplying powers, so you're adding the exponents and leaving the base the same. It ends up being x to the power 4, so what do you add to 2 to get the exponent 4? That would be x squared. X squared times something gives us x cubed, x to the exponent 1, and x squared times something gives us x squared. As a matter of fact, there will be no other variable there. So we just have a 1 there, And I'll just erase that and move that to the center of the bracket. So 3x squared times 3x squared gives us 9x to the power 4. 3x squared times 4x gives us 12x cubed. And 3x squared times negative 1 gives us negative 3x squared. And that is all there is to it. So here's your work. Please enjoy responsibly. See you in class.